Hello. In this video, I'm going to explain the basic simulation of the clipper circuits. So here, the aim of the experiment is to design and test bias clippers. We have to simulate positive clippers, negative clippers, and positive negative clippers. Okay. So what is the meaning of clippers? Clip means we have to clip off some part of the input. Okay. And at the output side, if I give some full sinusoidal wave at the input, output side positive waveform, positive side waveforms, some part of the waveform will be clipped off. Okay, remaining negative cycle will come as it is. Similarly, in the negative clippers, negative part of some part of the negative cycles are going to clip off, and it is also possible to clip both positive as well as negative parts of your inputs. Okay, so depending on your application, either you can use a positive clipper or negative clipper, or you can clip both the sides. So let me start with the positive side clipper. The circuit diagram for the positive clipper is this. You have to connect, you have to give some input here. Left side, you have to give some input. This is some suitable value of resistance I have to use. So that is best value of R. Value of R is, it is root of forward resistance and reverse resistance of the diode. So better let us choose either 3.3K by assuming forward resistance as 10 ohm and reverse resistance as 1 mega ohm. So root of forward resistance and reverse resistance. Okay, product of RF and RR. So approximately 3.16, or you can choose 3.3K or 10K, any value. Okay, we can use. And you have to, for positive clipper, the direction should, diode direction should be plus here, minus here, and similarly the voltage. So reference voltage also you have to use. If I don't use reference voltage here, it will be clipped, and this output will be clipped to, and it is always equal to zero point 0.7, which is the drop across the diode. If it is silicon diode, zero point 0.6 will come. If it is germanium, zero point 0.3 will come. So how much voltage you want? Additional voltage you have to here. For example, if I want to clip at 2 volts, zero point 0.6 is here, so remaining 1.4 I have to give here. Suppose if I want to clip all the voltages above 3 volts, zero point 0.6 here, so remaining 2.4 volts here. So now whatever input is there during the positive off cycle, diode is forward bias and acts as a short circuit, and it is assumed as voltage source with VD, okay, zero point 0.6. So if you have some additional voltage here, so your output is restricted to this voltage. It is in series, two batteries are in series, VD plus V reference. Okay, so depending on, you can here V output is V reference plus this one. Always cut-in voltage of the diode is, for a silicon diode, it is zero point 0.6 volts. So if I want to clip at 2 volts, okay, I want to clip at 2 volts, then you have to give 2 here and 2 minus zero point 0.6, it is 1.4. This is gamma zero point 0.6 only you have to consider here. Then it will becomes 1.4. So let me simulate this. So I want one diode 1N4007, one resistance 3.3, one reference DC power supply of 1.4 volts, and function generator use, or you can also use AC voltage source. Single AC voltage source you can select here, or function generator, and one oscilloscope, and one ground symbol. Let me simulate first positive clipper, next negative clipper, next both side. So please observe, and parallelly you also do along with me. So open the multisim student version, go to file, new. I'll place one by one. First I am placing one resistor. So I'm going to place one resistor. Go to place component. In the group already it is in the basic. So in the basic, resistor is there. You select, you click on 3.3K or You can click on 1K in place and double click and you can change the value to any desired value. So I'm directly selected this 3.3K is selected. Now I want one diode. It is there in the basic diode is there. In the diode, what shall 1N4007 you can select. Okay. Any diodes, you can use all the different diodes are available. You can select any diode. I am selecting 1N4007. So I want to place vertical. So press Ctrl R button. So I want like this direction. So place here. I want on reference voltage. So that is there in the group. You have to go to sources group. In the source group, click on power sources. Above in that power sources, right side, AC power is there, DC power is there. I am selecting DC power. Click OK. Okay. Next, I want one ground also. So same in the power source, ground is there. You select that and place here. So now this is close. You can close it. Okay. Now I want to give input now. So right side here, right side of the tool we have multimeter, function generator. You select function generator. Place here. I want to output device, oscilloscope. Select oscilloscope and place here. Now all the components we place still connection is pending. So click on this edge, click and come down. Click there, come down. Click here, join this. Click here, join this. Now input should be connected to this now. Click here. Always input positive should connect positive and can connect to this common or you can connect to negative. I will connect to common ground. This common I'm connecting to ground plus and common ground. After that here output should be taken across diode. Okay. See wherever connection is there, this dot will come. This dot means there is a connection. This is a junction where three branches are connected. This is ground. If any connection is not connected, it will give some error. So now I will simulate this. Okay. See here I want to double click on the function generator. You can see this is the function generator. Double click on this. Frequency is 1 hertz. I will change this one to 1000 hertz. Okay. And amplitude is 10 volts or you can give 5 volts. Okay. Now by default waveform is sinusoidal. You can select triangular wave. You can select square wave. Okay. Now it is changed. Now click on this run button now and see the output. Output is always connected across diode and this power supply. So always it will be DC only. So this is at 12 and this is actually I want 1.4. No, I have to stop this. I have to change this. This is zero point 0.6. No, remaining voltage is 1.4. I have to connect. So change that value from 1. Well, default value is 12. So I am changing to 1.4 volts. Now, if I add this zero point 0.6 plus minus zero point 0.6 plus minus 1.4, it is 2. So 2 volts it is restricted. All the voltages above 2 volts, okay, the diode is on and you are going to get horizontal 2 volts. You will not get output above 2 volts. All the voltages below 2 volts are actually passed. So now we'll double click on this. You can see the output. So by default, if it is coming like this, you have to change the this scale, time scale. This is input. I think it's coming as input only. 1 minute. When you run this, now you can see now. Input is, if I click single, please observe the output. What is the voltage it is coming? Okay. Now I will change the division to 2 volts. It is connected to the which channel? Observe. It is connected to channel A. There are two channels, channel A and channel B. Each division, this dotted box now, each division is 2 volts, sorry, 5 volts. So I will change this one to 2 volts. Each division in this 2 volts. So now you can see from 0 level, it is one box. One box into 2 is 2. So output is limited to 2 volts. So it is a positive clipper. Okay. In the positive clipper, okay, output, so you can see the input is full wave, actually output in the positive of cycle this part is clipped off. That's why it's called as positive clipper. In the positive clipper, okay, positive part of the, okay, waveform is removed. This is positive peak clipper. Okay, this is positive peak clipper. Positive peak clipper is called as negative clip. I think negative clipper. I think you can see that. So this is positive peak clipper. Okay. Now I will show the input also because two channels are there. In this channel, let me see the input waveform. So let me color also. Click on this. Go to select color segment. I am giving green color for the output, and I'm using second channel also. I am going to connect to see the input also. So input is you can click here. Okay, input is full wave now. I want to see, I think same correct before diode for resistors. Let me connect at the input side. 1 minute. I can see the input here only before that. Okay, can connect here. Another channel input side I have to connect. So I'll bring from this side so that no confusion. Input directly I'm connecting across input and ground you can connect common ground, no problem. If don't connect here, you have to connect here because this is connected to this. So now channel B, this I'll change, click on this, go to segment color, change it to green color or some any color you want. Okay, you can see now in the CRO, you can observe the input in green color. You can set the color to any color you want. This is just to differentiate which one is input, which one is output. So now click run button. Now you can see both actually. Both I'm giving 5 divisions per scale. Okay, na. So this is single. If I click auto, it is continuously running. Okay, if it is 1 kilohertz, you can stop single. If it is 50 hertz, 60 hertz, even if I click single, it will not actually stop. Okay. So since I set the frequency to 1 kilohertz, after single, it can, after one single plot, it will stop. Auto means continuously. Now I am clicking single, and reverse means background. It is coming in the background color. You can change to black color or white color by clicking reverse. Okay. So now I'll explain once again. Input is what? Channel A is output. See, channel A is connected across output side. Channel B is connected across input side. Input is this left side, output is right side. So channel A is this. If I channel A, if I ground, this is 0 means ground. If I ground this, only one waveform you are seeing, that is green color, which is input and which is AC. Okay, which one we grounded? Channel B we grounded. The channel B should be AC. Input should be AC. No? After that, now if I ground channel B also, now no output will come because both the channels are grounded. This is also ground. This is also ground. Now I will see only output. So output means this is channel A is output. So instead of 0, I am changing to now DC. Now you can see output. If I click this AC now, automatically it adjusts this area to this area. So which is wrong. Always output for clipper circuit it should be DC. See here, if I click AC, the area under this and area under this both will be equally divided. So that's why the waveform shifts. But if I click DC, observe the waveform. Now what is the one division? One box is equal to how much? 2. So it is actually from how to check the output from 0 to here one box. 1 into 2 is 2 volts. Output is limited to 2 volts. So it is clipped all the waveforms, input waveform above 2 volts. So it is positive peak clipper. Okay. Now same problem I will ask you to change it to uh, uh, 3 volts. Okay. 3 volts. Then stop the program. So here how much is there? 0.6. So here 1.4. 1.4 plus 0.6 is 2. You are getting 2. So now instead of 1.4, if I want 3 volts, so double click, you change it to 2.4 volts. So it will be converted into 3 volts clipper. So it is a positive clipper which will clip all the voltages above 3 volts. So below 3 volts it will allow. Now run this. See now from here it is shifted to here. It is almost 1.5 box. This is one box, one and a half. One and a half into 2. One and a half into 2 is 3 volts. You can click in. Now I want to see input also. Click from the ground 0 to change it to AC. The input is full green color and it is overlapping. Output is coming here. Input and output is the input, is the output. Now I want to see this transfer characteristics. Okay, like this or like this transfer characteristics. So this waveform is we are getting this output now, expected output. In the expected output, this is 0, clipping edge occurred at 2 volts. This is x-axis time, y-axis is voltage. This is time versus voltage. Now transfer characteristic is it is voltage versus voltage, not time. It is both x-axis and y-axis are voltages only. X-axis is input, y-axis is output. So I should get like this. So what is the meaning of this? If input is same as output, if I plot a graph, you will get for 2 and 2 and 1 and 1, 0, 0, minus 1, minus 1, minus 2, minus 2, minus 3. So if I join this, you will get diagonal line. But for the input side, you can see for the input 3 volts, output is limited to 2. For 4 volts also 2. For 5 volts also 2. So that's why here you are going to get horizontal. If it is diagonal, output is following the input. But if the input is increased to 3, 4, 5, output is not increasing. Output is this and it remains at 2 volts only. Okay. So that's why you are going to get horizontal here and here. For any voltages greater than 2 volts, output is limited to 2 volts. That is the meaning of this. Below this, output is following input. For above 2 volts, output is not following, but output is remains constant at 2 volts. How we got 2 volts? It is nothing but diode drop plus reference voltage. So now let us verify this output. So for this, already it is there. Click on A to B or B to A. So let me click AB. That is channel A versus channel B. See, channel A versus channel B. For to get have this channel A versus channel B, please remember A should be connected to output, B should be connected to input. If you are getting opposite, then you click B versus A. Okay. By mistake in the lab also, if you are getting opposite, just change the input and output channels. So you are going to get this. So here you can see up to 3 volts. Now I change it to reference 2.4 now. So I will change once again back to 2 volts only. So I will change this value to 1.4. I will verify once again. I'll change this one to 1.4. So now once again run. See here. This is right side also one box is 2. Channel A, x-axis. It is input versus output. So it is one box into up to 2 volts input is following output. So diagonal line will come. After that input is increasing to 3 volts, 4 volts, 5 volts, but output is not increasing. Output remains 2 volts only. That's why this portion horizontal. Below 2 volts it is following. So this is transfer characteristics. Okay. So this is about positive peak clipper. Okay. Positive peak clipper. In the positive peak clipper, diode connection vertically you have to connect. Diode drop is zero point 0.6. How much voltage you want to have? Add 0.6 to that much. For example, for 2 volts, so 0.6 plus 1.4. For 3 volts, 0.6 plus 2.4. For 4 volts, zero point 0.6 plus 3.4. So change it and you will get output. Okay. Thank you.